Hello, welcome back once again. Today we have another interesting transcendental equation, and here we'll be solving for the real value of x. We have 2 to the power of x minus 1 plus x equals 1. Here, let us solve for x. Now before we proceed, let us take note of this. When we have a to the power of b minus c, this is equal to a to the power of b divided by a to the power of c. Therefore, this term right over here with this power of x minus 1, we can write it as 2 to the power of x divided by 2 to the power of 1, which is 2. Then here we have plus x, then this is equal to 1. Now from here, this is over 1, this is over 1. Now let us look for the LCM of 2, 1, and 1. So obviously, the LCM of 2, 1, and 1 is equal to 2, right? So let's go ahead and multiply each term from both sides by 2. So we have 2 multiplied by 2 to the power of x divided by 2, then plus 2 multiplied by x divided by 1. This is equal to 2 multiplied by 1 divided by 1. So from here, this will cancel this. We're left with 2 to the power of x. Then plus, here will be 2x, and this is equal to 2. Okay, now from here, subtract 2x from both sides, so we get 2 to the power of x will be equal to this 2 right over here, minus 2x, right? Now, let us change the sides of this equation. So let's make this side the left-hand side, this the right-hand side, but that will not affect the equation. So we have 2 minus 2 times x, this is equal to 2 to the power of x. From here, 2 is common, factor it out, so we have just 1 minus x here. Then this is equal to 2 to the power of x. From here, let us divide both sides by 2 times 2 to the power of x. So we have 2 into bracket 1 minus x divided by 2 times 2 to the power of x. This will be equal to 2 to the power of x divided by 2 times 2 to the power of x. From here, this will cancel this, and this will cancel this. Take note of this, 1 over a to the power of n is equal to a to the power of negative n. So this is 1 over 2 to the power of x, which we can write as 2 to the power of negative x, right? So that will be 2 to the power of negative x from here. Then this will be equal to just 1 over 2. Now we're trying to make the power of 2 here to be equal with the coefficient. So we all know that the number we multiply to both sides of this equation must have a base of 2. So that when we sum the powers, we can get something exactly like this. And the number we're talking about should be 2 to the power of 1. Recall that a to the power of b multiplied by a to the power of c is equal to a to the power of b plus c. So when you multiply both sides by 2 to the power of 1, we get the sum at the left hand side, the power sum, as 2 to the power of negative x plus 1, which is same as 1 minus x, which is equal with this coefficient here. So we have here 1 minus x times 2 to the power of negative x, then times 2 to the power of 1. This will be equal to 1 over 2 times 2 to the power of 1. So from here, we have the same base using this rule here. So we add the power, so we get 1 minus x times 2 to the power of 1 minus x. Because negative x plus 1 is 1 minus x, this will be equal to 1. Now from here, let us recall another interesting property. A to the power of b, we can write it as e to the power of this b here, multiplied by the ln of the base. So here this will become 1 minus x times e to the power of 1 minus x multiplied by the ln of the base, which is 2. Then this will be equal to 1. Let us recall the Lambert W function. Remember the Lambert W function with the following argument: x times e to the power of x is equal to x. The power of e must be equal with the coefficient, right? And from here, we can't make use of this Lambert W function at this moment because the power of e here and the coefficient are not exactly equal. We just have a slight difference, and which is this one is being multiplied by the natural log of 2, but this one isn't multiplied by the natural log of 2. So we need to multiply both sides by the natural log of 2. So we have 1 minus x multiplied by the natural log of 2. This will be, times e, right? Raised by 1 minus x multiplied by the natural log of 2. This will be equal to 1 times natural log of 2. From here, let us make use of the Lambert W function on both sides. So we can see from here, this will simplify to 1 minus x multiplied by the natural log of 2, which is equal to the w of the natural log of 2. Divide both sides by the natural log of 2. This cancels this, and here we have 1 minus x is equal to the w of the natural log of 2 divided by the natural log of 2. So here we're solving for x, so x will be equal to, if 1 minus this will give us this, therefore this is equal to 1 minus this, which is at the right hand side. So we have 1 minus the w of the natural log of 2 divided by the natural log of 2. Which, when I use my calculator, this gives me a very beautiful approximation of 0.358814255, and this is the solution. Thank you for watching. Please kindly subscribe to my channel. Also like, comment and share. Bye bye.